1, 2, 1, 2, 1, 2. Yes, hi. So we're gonna get started again if everybody wants to get seated. Thanks. I actually was asked during the break what a TDK is, and I recognize that I never explained what it means. So TDK is Technical Development Kit, and it's basically this little boy here, and has everything that a Ford infotainment system has in it, so you can develop against a real head unit in a car, as opposed against an emulator and stuff like that. So that's the TDK, if anybody's wondering. Give people a little second to come in back there. Right. So I hope you're all refreshed, had coffee, and are ready for the next 3 hours of fundamentals. Just joking. It's going to be quick now. So we were talking, just to recap, we were talking about all the different RPCs we have, and this was an overview about the way you interact with the head unit on an RPC level, and the next step is how does the interaction look like from a flow perspective, sequence diagram perspective. So initial connection. We're going to use all RPCs we got to know now, and initial connection is done via register app interface. Obviously, as I said before, register app interface is always the first thing that you send from a mobile device to core, and core will respond. At this point in time, your app will be displayed on the head unit. So if you register app interface, your app will be there. What you're going to do is do a list files. So we have a little feature implemented that enables you to check what files you uploaded previously. So if you connected to that head unit before and you uploaded your app icon before, you don't have to upload it again. So if you call list files an RPC that I did not speak about before, you will get an array back of all that your app has uploaded before and that are still available on the head unit. Now, if your app icon is in there, great, you can reuse it right away. If your app icon is not in this list, then you use a put file and upload it to the system. And then you have it uploaded on the system, file is sitting there, your set app icon, I'm going to come closer to antennas back there. You set app icon, and the app icon will be shown on screen. Yes, please. The question is, does list file give any type of currency of the freshness of the file when it was uploaded and stuff like that? List file only gives you the name. So generally, if you're unsure if this is new or old, the best idea is to delete it and upload it again, so that you can do that. It doesn't give you currently any timestamp or something like that. After you set the app icon, you will get an on-HMI status. So on-HMI status will inform you about your current status on the system, as I mentioned before. If you just registered and you're just sitting there and the user did not start you as an app yet, you will get on-HMI status of none. So this will mean you're sitting there, the user didn't start you, you can't interact with the system. Please don't start showing stuff or speaking something or whatever. All these requests will be denied by the system. Also, while you're sitting in on-HMI status none, if you send too many RPCs and we deny too many RPCs, you will be disconnected. So we don't want to have apps sit there and send RPCs, send RPCs, send RPCs, and slow down the system. So we disconnect our apps that spam us while they shouldn't send any RPCs. Now, on-HMI status in this case is none. One note on this, if you has background permissions, therefore, if your app is allowed to interact with the customer from the background, your initial on-HMI status will be background, not none. So when you have background permissions, you have on-HMI status background, and you can, for example, send an alert to the customer and show him something. As I mentioned earlier in our example of the scoring app, this app will start with on-HMI status background and will just sit there, and then when your team scores, we'll send an alert. It will not start in none. Every app that does not have background permissions will start in HMI status none. That's a tricky one, so if there is any further clarification needed. So now you're sitting there, you're waiting for the user to start your app, and when the user goes to the app screen and presses your app icon, your app will become foregrounded. So this is the sequence that will go down in that event. You will get on HMI status full. That is the first thing that will happen. Your app will be informed that a user started your app. So we start this first full, we call this first full most of the time, so that means that's the first time you get started, you get into the foreground. Now, your app has to do stuff. You have to populate the screen, otherwise the screen will be empty. So it's very important for the app to go and start and send, for example, a show command. So the first thing you want to do is not let the user sit there with an empty screen, show him something. So Spotify will start populating artist and artist and track name to the screen. Other apps will give status information. So let's say you have an app that gathers vehicle data. You can let the user know that your app has been started and is now ready to gather vehicle data or other information. But most importantly, don't leave the screen empty. Show the customer what you're doing. Keep him informed. Now, after you populated the screen, the user sees something, you're going to want to add commands to the system. Now, usually what we tell people when they convert an app they already have in the market to an app that runs in the car is, think about the use cases that make sense in the car. Don't just port everything over to the head unit. Think about what people want to do while they're driving. So for example, Spotify says, okay, users may not want to search through the whole library because searching through 20 million different tracks takes a lot of distraction from the driving task. So what people want to do is access their previously saved playlists or artists or albums. Now, Spotify then sends these different features or these different commands to the head unit as an add command. So choose playlist, choose album, choose artist. With the add command sent to the head unit, these items will be populated in the menu list, and the customer will be able to choose them via voice recognition. So at this point, when you send an add command and you get a successful response back, the customer will be able to choose your command from the list or via voice recognition. Every command you send to the system will have a unique ID that you give it. So the app has to keep track of what ID correlates with what feature. So if you give a command the correlation ID, the command ID 13, when the user chooses that item via menu, you will get the information back that the user chose the command with the ID number 13. So you can then go and do whatever it is your app does when this command was selected. Subscribe buttons. So in the case of Spotify, what they want to do is they want to show you music and they want to enable you to play pause or to skip music. And they don't want to just do that from the screen, but they also want you to be able to control the app, for example, from the steering wheel. Because that's the benefit of App Link and Smart Device Link is you can bring a car and integrate it into the, take an app and integrate it into the car so that you don't actually have to use the screen at all times. You can also use voice recognition or the steering wheel controls. So with subscribe button, what the user can do or what the app can do is the app says, I want to subscribe the button skip right or subscribe the button skip left. When the user presses that button, the app will be informed that the button has been pressed, and then Spotify skips the track, or if it's a skip left, goes back to the beginning of the track. Now, a couple of remarks on subscribe button. There's an enum, there's a list of buttons that you can subscribe to, and you can find that in the documentation. Play, pause, skip left, skip right, preset buttons if you want to store presets, if you're a media application, work on there. But also, not all apps can access. So if you're a non-media app, if you don't have media content, it doesn't make sense for you to have the skip button subscribed. Because obviously, when I listen to Spotify in the background, if I press skip, I want to have Spotify skip the track and not your non-media application use it. So non-media applications cannot use play, pause, skip left, skip right, or the preset buttons. That is reserved for media applications. But then there are other subscribe buttons that people can use, and you're going to find all the information in the documentation on that. And then the last thing you want to do when you get started, you want to create all your interaction choice sets. So interaction choice sets are a very vital part of App Link, Smart Device Link, because interaction choice sets are the fundamental lists that you use when you interact with the driver. Now, an interaction choice set needs a little bit of time on the head unit to be created, because let's say you have 100 playlists. And all these 100, you send the list of 100 playlists to the system. The voice recognition system on the head unit has actually to create a database of whatever it uses for its own recognition internally. Creating this database takes a while. So what you want to do is, if you have static lists, just upload them right away after you connect it to the system, and don't wait for the user to interact. For example, Spotify has all your playlists. When you connect to the car, you know already what playlists there are. Now, when Spotify waits to create this list until a user presses the button choose playlist, the app will have to upload it, wait for a success response, and then send the perform interaction. So the time that it takes to create your interaction choice set, you can move that to the beginning when your app connects the first time. And then when the user choose playlist, you can go right away and send the perform interaction. This will shave off vital seconds of the interaction and make it much snappier in general. This is valid for all static lists. If you have a dynamic list that's based on a location or something like that, for example, there's no way around of creating it in the moment that it's needed. So there will be some time delayed until it was created. The question is it asynchronous? All our RPC calls are asynchronous at this point in time. Some are faster, some are slower. So a show will be really fast because we just have to put the text on the screen. You will get a really quick response. A create interaction choice set is a relatively slow RPC because the voice recognition databases have to be built in the background. And only if they have been completely built, you can actually use it. So that will be a little bit slower. But all of them are asynchronous. Yes, sorry.
So since you say the create interaction choices takes a while, you should do it as soon as you're connected. I guess to clarify my thinking, are you saying that once you get like on HMI status none, let's for example, you can send this command then or?
No. So the question is, can you send a create interaction choice set when you are in HMI status none? Or when should you send it? So I deliberately put it into this slide because you should only send it when you're in full. While you're in none, you should basically sit in the background and idle and not do anything. You can imagine the problem when you plug in your phone and you have 10 apps on your phone, all connect at the same time. Everybody starts sending interaction choice sets, and the system is completely occupied by creating these voice recognition databases. So you should create them when your app goes into HMI status full. And if I say it takes a long time, I don't mean it takes 10 seconds, 15 seconds, 20 seconds, but it takes a perceivable time for the user that delays their interaction after you chose a menu item. So when you look into like user interaction handbooks and stuff like that, they always talk about like 200 milliseconds response time, stuff like that. And so when you use an interaction choice set, you will get over 200 milliseconds if you do it in a moment of interaction. If you do it up front, it will already be there, and then you can get into this 200 milliseconds range on reacting on a menu input. Other questions? Okay, so this is what to do when the customer selects your app. Now, typical interaction. So basically, the slide before was what you do when the app starts up, and then you sit there and you play your music, and the user doesn't really interact with you. You get to the next track, you send show again, show new information on the screen, but there's not too much interaction going on. Now, this is what happens when the user actually wants something from you. So we start off with the user selected choose playlist command, and this takes the Spotify example just because people are very familiar with how it works. So the user goes into the menu, chooses, selects the menu item choose playlist, either via voice recognition or via the menu. What you will get is an on-command notification. We talked about notification. All the RPCs that are triggered by the head unit and go to the mobile side are notifications. So you're going to get an on-command notification with the command ID that the user chose. Now, this command ID will tell you which item it was, and you can then react on it. So I put it in there with a little note next to it. So if you don't have a choice set already created for this interaction, it's the time to create it now. Best case scenario, you already created this static list on app start. If you didn't do it, you can do it here. And very important, you have to wait until you get a create interaction choice set success back before you go to the next step, because the next step is dependent on the list being completely created. So perform interaction is the RPC that you use to actually initialize the interaction with the customer. Now, when you send that to the customer or to the head unit will present either a voice recognition dialog or a menu dialog to the customer. You can select what you want. You can say, I want to have a menu-only interaction, or you can say, I want to have a voice recognition interaction. And in the best practice part, we're going to talk about when you should choose which kind of interaction. But generally, you can do either of them, whatever you want. Now, if you call perform interaction before you get a create interaction choice set success back, your perform interaction will be rejected. We can only do it if we have a VR database built, obviously, because otherwise the voice recognition system can't get the input from the customer. So this is a very typical issue we see with developers in the beginning, that they send off a create interaction choice set and don't wait for the response, but just send out the perform interaction right away afterwards. This is a little bit due to the fact that for most RPCs you send, you can basically disregard the response. So for example, for a show, you should just look if it was successful or not. But if you send a show and if you send a create interaction choice set right after each other, you can send them off before you get the responses back. But in this case, you actually have to wait on the response to send a perform interaction choice set. Now, when you get the response of the perform interaction choice set, getting the response of the perform interaction choice set can take a while, because the response will include the item the user chose. So if the user takes 20 seconds to choose an item from your list, the perform interaction response will take 20 seconds to come to you. So what your app will do is just sit there, idle, and not do anything. Just wait for the input, basically. The user selects one of the items, and you know then what playlist the user chose, because every item in the create interaction choice set has an ID, a so-called choice ID. So the choice ID is unique across all choice sets. And so you can identify the playlist that you previously defined and then start playing it. So what you do is you send a show, new artist, new track name, update the playtime and stuff like that on the screen, and then you start playing the new track, and then you're done. Interaction is done, you sit there and you idle. And this kind of interaction is the most common interaction in smart device link / app link, because it gives the user the ability to choose something from a list. It can be a very long list. So just to give you a perspective on size, create interaction choice sets can have up to 100 choices in them. And you can upload multiple create interaction choice sets to the system. So a perform interaction takes up to 100 choice sets. That means 100 by 100 items in maybe the worst case scenario. Obviously, you should not try to overwhelm the driver. So when you create an app, you have to be conscious about how many items you send to the driver and how many items you have him to choose from, and try to minimize that as best as possible, and always find a trade-off between functionality and driver distraction in the car. So we're going to talk quickly about creating the proxy. Now, this is first actual code we're going to see. What you do to connect to the car. This is the way in the code for Android that you create a new proxy object. The proxy object is the main object you handle. This object will allow you to communicate with the head unit. So if you have the library included in your app, you can use new SDL proxy builder.builder, and you will get a proxy object back that will enable you to do the communication. You see in this main builder function, you put in your app ID, your app name, and if it's a media app or not. So this is the very basic functionality of this class. So the very basic builder function with only the necessary items. There are overloaded functions on this where you can put in your TTS name, your VR synonyms, and all the other things we talked about. But this is the way to get started with like a very first connection. Okay.
So when you set your choice set and you do a perform interaction, one of the ways you can do it is using voice, right? What if the system does not recognize what the user is saying? What happens then?
Okay, so the question is, when you do a perform interaction via voice, what happens if the recognize what the user is saying, right? So the answer to that is there are 3 different options to use perform interaction. There is manual, which will bring up a manual interaction. There is VR, which will bring a VR interaction. And then there is the magic both. So both will actually present a VR interaction to the user first. Now, if the user cancels that or is not able to give an input, first of all, they can always say help, and they will get all the choices. But second of all, if they cancel the VR input, they're going to get the menu after that. So they can go into the menu and select one of the items. So one note on this. From these 3 different perform interaction types, VR is basically never used. What you do is you either use menu or you use both to give the user a fallback into a menu if you use voice recognition.
Is there a way to access the raw audio stream to send it to a third-party speech to text?
The question is there a way to access the raw audio stream to use it in your app to send it off board or something like that? The answer to that is yes, there is a way. There is an RPC that we call audio pass-through, and I actually don't know why I didn't include it in that presentation, but audio pass-through enables you to get the raw audio from the microphone in the car. Now, it doesn't work with perform interaction or create interaction choice set because it's not structured from the smart device from the car side. What you do is, as an app, you send audio pass-through, and the head unit will bring a pop-up basically indicating that now all the audio goes through to the app, and then you get a binary stream of audio to your app, and you can do whatever you want. And we use that, for example, for our Alexa demo at CES. We give the app the raw audio stream, and that sends it off to the Alexa backend and gets the response and sends it back up. So there is a way to do that. Yep, in the back. So the question was, how do you file voice commands if you use audio pass-through, I assume? So you have to imagine audio pass-through and the add command set. These are 2 different things, really. So you have an app that you have on the market that is not a voice app. Let's go away from the voice assistant for 1 second. That is just a normal media app or sports app or weather app or news app. You won't have any voice capabilities in your app usually, so you use add commands and you use all the voice capabilities that the sync system gives you. Now, if you are a specialized voice service, like, for example, Alexa in our demo at CES, you don't have to create too many commands in the menu because you already have your commands internally, and maybe you have a natural language detection, so you don't even know what the structure of your commands looks like before you send it to the back end. So what you usually do is, if you have specific features you want the user to be able to trigger from the menu, you can add these commands. But for example, for Alexa, we don't have any add commands in there because if you ask for the weather, Alexa will recognize that in the backend. There's no button to ask for the weather in a specific city. So you don't have to use perform interaction. You don't have to use add commands that much. Again, it's always a question about functionality in the car, in the driving scenario. So you try to make your app as accessible as possible for the driver. Now, if you're a voice-only app, it's fine to use audio pass-through most of the time. Yes. So the question is there a way to start the app from the head unit via audio or via voice recognition command? Yes. So when you register your app with the head unit, you give it a VR synonym. Now that VR synonym is the app name, basically. So when I press the push-to-talk button on the car and say Spotify or Alexa or whatever other app name, the app will start. Now, when the app starts, you as an app get HMI full, and you know that you have been started. And you can create a voice pass-through interaction right away and get the input what the user says.
But I want to pass through all that steps, right? When I press a button, it says, please say a command, then I say a command and all that. So I don't want to go that to and fro thing, right?
So at this point in time, that is the way. So the question was, is there a deeper integration into the system? At this point in time, there is no deeper integration into the system. What you have to do is you basically, your app gets started, and when you send audio pass-through, when you have the pop-up on the screen, then the audio gets piped through. You don't get the other stuff before. Stay tuned on what we're going to